Assalamualaikum warahmatullahi wabarakatuh. Good evening, everybody. This is our presentation for the ICUPERTAIN 2020. Our title is Digital Twin for Subsea Pipeline Corrosion Monitoring Location based on ILI-MFL Pipeline Operator Forum and Potentiodynamic test. Me as presenter, Eka Manishuryana, and this is our team for this presentation. In any oil and gas field in Indonesia, we know about the many characteristics of fluids, of gas, and also the produced water, and something like another fluids have many typical condition or different specific condition in operation. This is the Indonesian field of oil and gas and our experience. The background of this research, we know about this COVID-19. We have the limited personnel mobility and also the restriction to access the field because the COVID protocol, also the isolation, swab test, flight and sample protocol, and also the another health protocol. Because of this limitation, we know this is the several conditions to inspection pending, and also the adequate data for inspection, and another case because this is a very required to we update the limiting data to the risk unmitigation, and also the failure probability is increased. This is conceptual development for our research. This is we have the any different data and also the defect or damage mechanism condition from the ILI-MFL. We have the POF diagram. We compare the specific condition for circumferential grooving, let's say some pitting or axial grooving. We have the any sample of damage mechanism, and this is the any sample of damage mechanism we identify to making the some copies, or we call the digital twin, for testing in galvanostat or potentiodynamic test simulation. This is for the pipeline integrity and inspection strategy. We know if we operate the pipelines, we have the typical condition from the risers to the MLV or something like jointy, and also the atmospheric field in soil and also in seawater. This is condition have the another specific corrosion damage mechanism. We have to inspect by any probability of detection capability of each the specific inspection technology. Let's say we just mentioned about the ILI-MFL magnetic flux leakage inspection, which this is have the capability for detect for the inline defect and also from the internal and external defect condition. This is for the manufacturing specific differentials about the wall-thickness. We know in manufacturing we have the 20.5% tolerance for any line pipe mechanical processing, and also the thermomechanically controlled processing. We have the any differentiation about the wall thickness condition. This is our methodology to identify about the digital twin. We have the starting from the any damage mechanism. We have the MFL color contour. We copy to the condition of the damage mechanism morphology, and we have the copy by using the potentiodynamic galvanodynamic test, and we have the any data to use the characteristic. Also we consider by using computerized fluid dynamics to identify the flow condition. We know in oil and gas operation we have two conditions from the sour condition and also from sweat condition by effect of CO2 and or also the effect from H2S. We have the two consideration in this research, and this is for example. We have the any data from the magnetic flux leakage inspection. I think this is data is larger data. Maybe for the first test or for one simulation or one data inspection, we collect maybe more than 300 data for calculate. This is why using one of powerful statistic method by using RStudio. We have the sample of corrosion rate, and also we have the sample for the potentiodynamic test, and we compare to the field data inspection to consider what? to consider the maximum allowable operating pressure by consider the corrosion rate and also the remaining wall thickness. This is a sample for data analysis. We're using SMA B31G by the formula using the original and modified formula, and we also compare for the modified SMA and also FPI, fitness for service 579, by substituting the SMA B31.8 formula to identify, because this original formula is applicable for piping, but for using the pipeline, we refer to Winston Revy. This need the modified by using the design formula by SMA B31.8. This is our example for consideration, and this is our reference for this research. And thank you for everyone. Assalamualaikum warahmatullahi wabarakatuh.